Okay, so in the last class we discussed this shortest job next algorithm. The basic idea is very simple, that given you have two or four, three jobs at hand, okay, you will go for the smallest one first, or the shortest one first. So here, as you can see, we have four processes. Among them, three is the shortest, so we will go with the three first. Then we six is the next shortest time, so we'll start with process one, and so on. So this was the idea, and after that we have solved it for another case where the job arrived at different amount of time, so everyone didn't arrive at the same time. And now in that case, what we have seen, that in that case there is a complication, that even though this is actually efficient algorithm, but if the jobs are arriving at a different amount of time, and two things might happen, that CPU might sit idle for a certain amount of time from 0 to 1, okay, because there is no job at that time. Secondly, what can happen is that jobs you see that here right now might be have the convoy effect. So what is a convoy effect? So convoy effect basically means that uh, the the job that is the largest arrived first, and he is taking a lot of amount of time, and that's the other jobs actually have to wait before he is finished. Now this is actually again another non-preemptive process. That means when we are allowing this one process to have the CPU, we are not taking it back. To solve this, okay, what they did, they actually came up with another approach, that is shortest remaining time. So this shortest remaining time, that is the one that we will discuss today. This is actually the preemptive version of shortest job next. So basically they work in the same way. The difference is that in shortest remaining time, what we do, after a certain amount of time, we actually keep checking whether the CPU is, whether there's any other short jobs or not. The basic idea is same. The processor is allocated to the job closest to the completion time, but it can be preempted by a newer job ready. So basically, in this one, uh, let's go for the example. Then see, we have different jobs arriving at a different amount of time. Now what's happened, that initially when the time was 0, okay, there was no other job. So even though that normally if all the jobs are here, you will obviously will not give the P4 the job first, because P4 you will give priority to P4. Why? Because P4 only takes 1 second, but P4 doesn't arrive until it is 4th second. So from 0 second to 4 second, you have 4 second at hand, and in that time there are other processes. So the process one, okay, arrived at 0 second, right? And it had 5-second burst time. So as there are no other processes, it was allocated the CPU, but it was allocated only for 1 second. And after that, okay, when in the 1th second, okay, there was another process came, that is process 2, which had only 3 seconds remaining. The CPU was taken back from process 1 and was given to process 2. And then process 2 keep executed for 2 seconds until at the 4th second, another process came, that is process 4. So basically what we're doing here, we are basically, after every second, we are checking whether there is any shortest process are there or not. So if I go for, if I go for another implementation, just give me 1 minute. So this is our example. We have this process numbers, we have this arrival times, burst time, we will calculate the completion time, turnaround time, and the waiting time. And we will also calculate another new term, that is called response time. What is a response time? Basically that whenever the process arrives and when you first allocate it the CPU, this is called the response time. So in the preemption, what we do, we actually allocate CPU, then we take it back, and then again allocate again. So a same process gets the CPU multiple time. So the response time means when was the first time it got the CPU. That means it could actually start its work. So anyway, this will be our Gantt chart. So let's start with the time 0. So at the time 0, okay, if you look, there is only one process, okay, that is process 1. So remember, we will allocate it for 1 second of each. So if you allocate process 0, okay, for 1 second, the remaining time will be 4. And as we have allocated for 1 second, in this one we will write process 0. So let's write, sorry, process 1. So this is the first input in our Gantt chart, that for 1 second we have allocated the CPU to the process 1. So we are done with this one. After that, okay, let's go back to our table and check. For after 1 second we will check. So now the time is 1 second, okay, and now we have two processes at hand. We have process 2 with 3 seconds remaining, and we have process 1 with 4 seconds remaining. Now which one is the shortest one? Obviously we can agree that process 3 is the shortest one, right? So we will allocate CPU to the process 3. Let me just make the boxes first. And so on. So we will allocate the CPU to the process 2. So this, and let's write P2 here. Okay, now this is the second. So now at the when the time is 2 seconds, let's again go back here. Okay, at the time 2, we have three processes: process 1, process 2, and process 3. Among these three, process 1 has 4 seconds remaining, process 2 have 2 seconds remaining, and process 3 have 4 seconds remaining. So which one is the shortest one? Again, the shortest one is this. Okay, so we will again cut down this one, because this is, and we will again allocate the CPU to the shortest one, that is our P2. So this will be 1 second remaining. Now the time is 3 seconds, right? Now at the when the time is 3 seconds, can you see that which one is the shortest one? Again, obviously that when the time is 3 seconds, the process 4 still haven't arrived, and obviously that shortest one is still the process 2. So let's write, let's cut down this one, okay, and let's make it 0. So this will be 0, and here we'll have the process 2. So you see, process 1, even though it got the CPU first, now it is actually waiting for process 2 to finish. So process 2 is finished. Okay, the time is 4 seconds, and now let's again go back here. So out of all the process, now we have the process 4 already arrived. Which one is the shortest? Again, the process 4 is the shortest, right? So we will allocate CPU to the process 4. Okay, let's allocate it. And then after allocating it, what we will do, we will assign the values. So this will be a 0, and this will be process 4. And the time is 5 seconds, 6 seconds, 7 seconds. Okay, now, so this is done. Now, when the time is 5 seconds, we have two processes left. This one is 4 and this one is 4. Now, among these two, the process 1 came first, so we will allocate it to process 1. Okay, so if we allocate it to process 1, the remaining time will be 3 seconds. So let's write process 1, and the remaining time is, where is it? So 3 seconds. Okay, and after that, again, if I compare at the time 6, if we compare between these two, as you can see, there is all the cases, it will be the shortest one. So it will be 2, and then again we'll allocate it process 1. Then again it will be 1, so we'll allocate it to process 1. And again, when the time is 8, this is still the shortest, so we'll allocate to process 1. So process 1 will get the CPU 1, 2, 3, 4, fourth time. So process 1, process 1, process 1, process 1. And after process 1 is finished, we have only process 3 left, so it will get it for the four times: 3, 2, 1, and 0. So I haven't properly have written this, but you can guess, right? So this will be process 3, process 3 again, process 3 again, and process 3 again. So we'll have allocated to 4 more times. Okay, so process 3, process 3, and process 3. Now if I go back, okay, so this was the step. So let me close this one and go back to our slide. So you see, this is what we have. So the process 1 got the CPU from 0 to 1 second, then process 2 got from 1 to 4 second. It was actually written directly, but here I have actually shown you that step by step, so that you can actually remember in the next time. Okay. So that's why it is from 1 to 4. Okay, it was not allocated at once, it was allocated step by step. Then process 4 got for 1 second, then process 1 got for 4 second. Again, it was not allocated at once, it was allocated 1 second at a time. And finally we have the process 3. So then after it, we can easily calculate the completion time. We know how to calculate it. We can calculate the turnaround time, we can calculate the waiting time, and so on. Finally, we have to calculate the response time. So this is new. So let's see how to calculate the response time. So if you see that process 1, he arrived at 0 second. And when is the time he got the first CPU? 0 second, right? So he had to wait 0 minus 0, 0. So the remaining response time for process 1 was 0 second. Let's talk about process 2. He arrived at 1 second. Instantly, if you see here, process 2 got the CPU also at the first second. So if I subtract this 2, he had to wait 0 second. Let's talk about process 3. Process 3 first got the CPU when the time was 9 second. When he arrived at 2 second. So if you do 9 minus 2, you'll have this 7. And this is how it actually, you calculate the response times as well.